Hey there, Rafid from CurlyBrackets here. In this video, I want to take you on a journey where I show you what math is really about and how it's so much more than the math that you are taught in school. Now, who is this video for? Now, of course, if you really like math already, I think you're going to enjoy this video. But this video is especially for those of you that don't like math. Maybe you even hate math. Maybe you're one of those people that consider yourselves not a math person. I don't know if you know about this, but there is a thing called math anxiety. If you want to learn more about it, you can do a search for it online. But in simple terms, math anxiety is this anxiety that you have relating to math. So, for example, if you see something written somewhere where there's some numbers involved, maybe some mathematical symbols, an X, Y, something like that, you actually feel anxious. Maybe you're having a panic attack. Maybe you just don't feel very good and you're feeling very scared, and you're definitely not able to think clearly. Maybe you have a mental block when it comes to this. You might have experienced this on a math test or doing math homework, or if you're told to do something on the spot by a teacher or something like that, because this affects, according to research, more than 60% of people. Now, I think this is really sad, and I think that one of the big reasons for this is because of how math is taught in schools. So, hopefully, by the end of this video, if you're one of those people, you're going to feel differently about math. And maybe you even want to give math another try. And maybe you'll even feel a little bit inspired to learn math. So, with that out of the way, let's begin. So I want to start off with a story. I want to tell you a story about, and it's a story about one of the greatest mathematicians ever, a German mathematician by the name of Carl Friedrich Gauss. Now, Gauss lived a long time ago. He was born in 1777. And when he was 7 years old, he was in math class. Now, Gauss was a very smart kid. He was a math prodigy. And in class, his teacher gave him and the other students in class a problem to solve. And the teacher thought that this is going to be a problem that are going to keep them, and especially Gauss, busy for a very long time. Now, this is the problem that he wrote down on the blackboard. He said, take the numbers from 1 to 100 and add them up. So he wrote 1 plus 2 plus 3, and of course you can keep going. And we can just write dot, dot, dot to say that we're going to keep going up to 98, 99, and finally 100. Now, after he had written it down, it didn't take more than 30 seconds to up to a minute for Gauss to figure out the answer. And he took his slate, and a slate is a kind of a mini blackboard that all the students had back then, where they could use a chalk to write stuff down there. He wrote down the answer on his slate, and he gave it to the teacher. And the teacher was dumbfounded. He was so surprised because Gauss had managed to write down the right answer, and incredibly fast. Now the question is, how did Gauss find the answer so fast? Now I'm going to show you how he did it, and we're going to work through this problem together. But if you want to give it a go yourself, feel free to pause this video right now and try to figure it out yourself. And then I'll come back and show you how he did it. All right, let's try to solve this thing. Now, before we take a look at the solution, let's try to really understand what this problem is asking of us. So this problem is saying, take the first 100 numbers and add them together. Now, the way that I've written down and the way that most people think is from beginning to end. That's kind of how our minds work. And if you have something written down, and if you are familiar with the English language, you live in the western part of the world, you are kind of conditioned to think from left to right. And I think that most people would think about this problem in this way, which would be, well, I can just start adding the numbers together from beginning to end, right? So I can do 1 plus 2, which I'll write down 3 here. Okay, and then 3 plus 3 is, of course, 6. Then I can keep going. So 6 plus 4 would be 10. Then I can keep going like this. And I'm going to find the answer this way. But this is going to take me a long time to do. And I'm not going to be able to even be sure that I did it right because I might have done a calculation mistake somewhere. But if I continue like this, I would find the right answer right here. But of course, this is now not how Gauss solved the problem, because he was able to do it fairly fast. So what did Gauss see that we haven't seen so far? Well, let me take away this and think about this problem in a slightly different way. So I could add up the numbers in order, but that's not something that we have to do. The teacher didn't say that you have to add it up from beginning to end. We can add it up whichever way we want to. The most important thing is that we add up all the numbers. So one way of doing it could be that you add up the odd numbers together and you find out what that is, and then you add up the even numbers together, and then you add those two numbers together to find out the total sum. It could be one way of going about it. But the way that Gauss did it was this way. He said, well, what is 1, the first number, and the last number, what do those two numbers add up to be? Well, of course, that's going to be 100 plus 1. That's 101. Okay. Then if we keep going, what's 2 plus 99? Well, coincidentally, that's also 101. I think you can see where I'm going with this. What is 3 plus 98? Well, that's also 101. And it turns out that you keep going like this, you're just going to find 101s. And so it's going to be a bunch of 101s together. Now, exactly how many 101s are we going to have? Well, we started off with 100 numbers. And we're taking the first number and adding it to the last number. So that's 2 numbers paired up. And then we're doing that each time. And we're reducing it like that. So it's going to be half of how many numbers we started off with, which is going to be 50, of course. So we have 50 of these 101s. Well, if we have 50 of the same number, in order to find the sum, we can just multiply those numbers together. So we can do 50 times 101. Now, of course, you can use a calculator to do this, but we can even do this in our heads, just on paper. So 50 times 101 is very close to 50 times 100. So what is 50 times 100? Well, 50 times 100 is 5,000. Okay, and then we got 1 left, 150 left. So what is 50 times 1? Well, that's going to be 50. And so 50 times 101 is just going to be the sum of those two things. So that's going to be 5,050. And this indeed is the right answer, which is what Gauss wrote down fairly fast. I love this problem because I think this problem illustrates the difference between doing something the textbook, old kind of boring way, where you're going from left to right, adding up the numbers one by one. It's going to take you a long time to do that, versus if you just take a step back and think about, what am I really being asked to do? Can I find some clever trick here so that I can spend a lot less time doing it? Which is exactly what we did, what Gauss did. Now, this is what I meant when I said at the beginning of this video about talking about real math. So let me go into this for a couple of minutes to illustrate the point more clearly. First, I'm going to get rid of what's written on the board. Let's see, select all of this and delete. And then let's go back to the marker. And then let's say school math, or just school on the left side, and we'll say real math on the right side. And then maybe I'll make a line here, like so. So, how is math taught in schools? Well, you have a math teacher, and the math teacher will have a bunch of lectures every week where new theory is presented. You're also going to have a textbook where usually you have the theory first, and then you have a bunch of examples that give you the method on how to get the right answer. And almost all the problems that you're solving are going to be calculation problems. Of course, in the beginning, it's going to be simple things like, 1 plus 1. And then later on, you're going to see, how do you do it? If you learn about adding up all the simple numbers, then you can use some methods for bigger problems like 584 times 35. You have a method here, you put the thing here, you multiply these, and you do all of these things. You learn how to do this as you go on. And as you go on, and by the time you've hit high school or something like that, you're doing kind of similar things, but with harder problems, calculus or algebra or something else. Now, all of these problems are, let me get rid of this, are calculations. Now, calculations, in understanding how to do calculations, I think is very, very important. But being able to do a lot of hard calculations by yourself, I don't think matters that much, especially not in the 21st century. Why? Well, because we got computers that can do it so much faster and so much more efficiently than us. And they're so much better at it than us. But as we saw in the Gauss problem earlier, if we use our heads a little bit, we can see some clever solutions to these problems. And there was a moment of discovery where we discovered that there's actually a pattern here. If you take the first number, you add it to the last number, you see something interesting happening. Now that we are much better at doing than machines. And in fact, that is what mathematicians spend their time doing. And they're really, really good at it. They try to discover new truths in math by going deeper and deeper and trying to solve harder and harder problems. And they even try to really make sure that what they've discovered is really the truth, that you can even prove that it is true. And so if you made a map of all of math like this, if you made a blob, being able to do calculations is a very small part of it. There's so many more things. There's like relationships between different things that you can understand. And then there are formulas that you can come up with. Remember the problem that we did? There's actually, if you go deeper into it and you take some other examples, like you try to add up the numbers between 1 to 200 or between 1 to 500. And then if you talk to a mathematician, a mathematician would think, I wonder what would happen if I go from 1 to any number, a number n. Can I come up with a formula that will let me get to the right answer regardless of which number I use, whether it's 500, 5,000, or 5 billion? That is some of the things that mathematicians work on. I really hope you enjoyed watching this video, and I really hope that you now have a much better picture of what math really is all about and what, thinking like a mathematician can mean. Math is, of course, used everywhere. Whatever type of profession you want to pursue, chances are that you're going to need math, whether that's engineering, computer science, law, medicine, biology. Yeah, pretty much everything relies on math. So it's something very, very important that you need to learn. And if you don't learn it, or if you don't feel comfortable with math, unfortunately, it's going to lead you to having much fewer options when it comes to working in different industries. If you'd like to learn more math, please feel free to check out some of our other math videos. And if you're really interested in this, you can also learn more about our math classes that we offer on our website, CurlyBrackets.no. And with that, I'll see you in the next one.